All right, so in today's lesson, like I just said, we're going to talk about rational functions. We're continuing to talk about rational functions, and now we're adding wholes onto these. And then after this, all of it kind of gets blended in together. So after this, you will always check for wholes. We talked about it earlier last week, but we said you would always start with your domain, and then after that, see if you could simplify. And this is the reason why. If you can simplify your function, so if that fraction can be simplified by canceling out a factor in the top and the bottom, and it eliminates that whole factor from your denominator, then your graph will have a hole. So if you had something that looked like, let's say after we factored something, let's say it looked like this, again, after you factored it, right? So the first thing we're going to do now is factor. Then we'll do domain, then we'll check for holes. So if after I factored, I could cross through x minus 3, what just happened is we eliminated what would have been a vertical asymptote, and we replace it with a hole. So there is a hole where x equals 3. Whatever I cross out, I would solve, and whatever that x value is the x value of the hole, okay? Now, if there was still another one, so let's say this x plus 3, x minus 3, and then x minus 3 was squared in the bottom, let's say, and I canceled, it would only cancel out one of those. So it's gone from my numerator, which means it's not a 0, but it is still in my denominator, which means there's still a vertical asymptote and not a hole. So in order for the hole to occur, you have to completely cross it out of the denominator, okay? Does that make sense? Understand the difference between those two. So in the top one, it is completely gone from my bottom. There is a hole there. And in the second one, there is still a factor left, which would mean it's not a hole. There's actually a vertical asymptote there. So to find the coordinates of your hole, okay, we would take our x, we would plug the x into the simplified function, and then find your corresponding y. So if I was to do it in that top example, I would take 3 and I would plug it in after I cancel them out. And then every other question comes after you cancel things out. So vertical asymptotes would now be after you cancel it out. Zeros after you cancel it out. Horizontal asymptotes after you cancel out. The only thing that comes before is your domain and the x coordinate of your hole. Those are the only things you will use your original function for, okay? So again, it would eliminate your vertical asymptote unless the multiplicity is higher in the denominator, like this bottom example. In this case, the multiplicity was higher in the bottom than it was in the top, so it didn't give you a hole. The vertical asymptote would still exist. And when you graph this on your graphing calculators, you will not see the hole. You have to be smarter than your graphing calculator, okay? When you go to the table or you go to find like the value at 3, it will say undefined. No, actually, it will give you the value. Sorry, it won't, unless it's a vertical asymptote. It will give you a value, so you have to know where it is. All right, so if you're looking at a graph, like if it gives you a function, it gives you the graph of the function, then this is how it could look like. So this would actually have a vertical asymptote and a slant asymptote. And then there's a hole here where x equals 3. So the hole coordinate you would always give, if it said what's the coordinate of the hole, this would be 3, 1, because that's where that occurs. And then you're going to use limit notation to describe the hole. So what's super important is you need both sides of this. I need to know what's happening as x comes from the left side, and I need to know what's happening as x comes from the right side. But on both of those cases, the y value is your answer. So the y coordinate of your hole, which is 1, would be where f of x is at the hole. So as x approaches 3 from the left, f of x equals 1. And as as x approaches 3 from the right, f of x also equals 1. Question so far? All right, so example 1 says find the hole or holes of the rational function if one exists, and then use limit notation to describe it. So the first thing we're going to do is factor my numerator. I can take a 10 out, and I get x plus 3. And then I'm going to factor the denominator. The factors of -6 that sum to +1 would be what? +3, -2. and x plus 3 cancels, which means the x coordinate of my hole is 3. Negative 3, because I would set that equal to 0. And then to find the y coordinate of the hole, I'm going to take what's left here, which is 10 over x minus 2, and plug the negative 3 in. So 10 over negative 3 minus 2 is 10 over negative 5, which is negative 2. So then when I went to graph this, you would see a hole at negative 3, negative 2, and I would say the limit as x approaches negative 3 from the left, and the limit as x approaches negative 3 from the right, both have f of x.
Wouldn't it be g of x?
Yes, thank you. Both have g of x.
Does it matter if we put f of x?
I don't know if I'd mark it wrong at that point. Just be careful because eventually your function questions will have more than one function, so you'd have to be specific to which one you're talking about. Yeah. This. Yep.
Is there ever gonna be a situation where like one of the if it's coming in from the right, it'd be different from coming in from the
So when you get to limits at the end of the year, that happens, and that literally we would say the limit does not exist. But this is, you're using limit notation to describe the hole, so the hole is always gonna have the same y. This is technically not finding the limit of our graph, but when we get to limits, yes. But for now, no. So before we move on, let's talk about this function as it is, okay? So first of all, if it had asked me all the parts of this, because your quiz on Wednesday is going to ask you domain, it's going to ask you for your zeros, it's going to ask you for any kind of asymptotes, it's going to ask you for the holes. So if I go first, domain is from the very beginning, after I factor, but before I cancel anything out, I would find the domain of this function. And I would say that neither of these can equal 0. So I would get x cannot equal negative 3 and x cannot equal positive 2. So the domain of this function would be from negative infinity to negative 3, then negative 3 to 2, then 2 to positive infinity. So that is that and the x coordinate of my hole are the only things I get from before I cancel out. Then go ahead.
So you do the domain.
Always the domain first. Yep. Factor, domain, hole. Then once you simplify, everything else is going to be based off of this function. So 10 over x minus 2. Let's talk about our intercepts. Are there any zeros? Like if I set 10 equal to 0, can I solve? No. So this is actually none of these. No zeros or x intercepts. Good morning. For the y-intercept, I would plug 0 in for x, and I plug it into the updated function. Thank you. So my y-intercept, I plug 0 in for x. 10 over 0 minus 2. 10 over negative 2, which is negative 5. Do you have a vertical asymptote? Again, we're using the updated one. We're using 10 over x minus 2. Is there a vertical asymptote? Is there a variable in the denominator? Yes. So I set it equal to 0. My vertical asymptote would be x equals 2. How about your horizontal asymptote? What's the relationship between n and m?
N is less than m.
Which means my horizontal asymptote is? 0. Good. Y equals 0. So all that stuff you now know. So if I had just done a rough graph of this, there would have been a horizontal asymptote at 0. There would have been a vertical asymptote at 2. I would have a y-intercept at 0, negative 5. And I have no zeros, which confirms it's not going to cross my x-axis. It's going to be here and here. And there's a hole at negative 3, negative 2. So 1, 2, 3, down 2. This would actually have a hole. So we're going to put it all together a lot of times because, again, on Wednesday, that's how it's going to be. You could get like an easy question where it just asks you for one of these things, but for the most part, you're going to be asked multiple parts of these. All right, example 2, find the whole of the rational function if it exists, and then use limit notation. So I purposely put this one in here because look at what's in the numerator. Do you remember what this is?
It's a triple.
Good. It's the sum or difference because it could be either. This time it's the difference of perfect cubes. Do you remember how to factor perfect cubes? Do you remember SOAP? Did anybody teach you SOAP? SOAP. Okay. So if these are both perfect cubes, which they are, right? X to the third is a perfect cube and 125 is a perfect cube because that's 5 times 5 times 5, okay? Then this is the difference of perfect cubes. And the way we factor the difference of perfect cubes is you cube root each of those. So if I cube root x to the third, I get x. If I cube root 125, we get 5. And then I'm going to set up 2 parentheses. The first parentheses is just those two, x and 5. We're going to come back and fill in the signs. The next parenthesis is the square of the first one, x squared. The square of the last one, 25, goes to the end. And then the product of the two is the middle, so it's 5x. And then SOAP is an acronym for same, opposite, always positive. So same, opposite, always positive means I match the sign with the initial one first. Same. Opposite, change it. This would be positive. And then the last one is always positive. Now this goes over x minus 5. So if I was finding domain, I'd do it from here. X could not equal 5. Okay, it would be my domain. This is just asking you for the wholes. Does something cancel out? Yep, my x minus 5 cancels out, which means the x coordinate of my whole is 5. And then to find the y coordinate, I plug it into the updated function, which is just x squared plus 5x plus 25. This would actually be a parabola because we got rid of the asymptotes. And then it says use limit notation to describe this. So as x approaches 5 from the left and as x approaches 5 from the right, what's my, this would be f of x equals what? 75. Questions on that one? All right, now we go to the table. So we need your graphing utility. The table will not be on the quiz, but will be on your test. All right, so let's say we don't catch that there's a hole at the beginning, right? Let's just say I take that function, I make that my y1. So my y1 is going to be x squared minus 16 over x minus 4. And then I'm going to find y1 of 3.9, y1 of 3.99, like all the way through. God bless you. So y1 3.9 is 7.9. y1 3.99 is 7.99. y1 3.999 is 7.999. y1 of 4, what happens? It's undefined. It actually says error, divide by 0. Then y1 of 4.001 is 8.001. y1 of 4.01 is 8.01. And y1 of 4.1 is 8.1. So without even looking at your function, because this is what will eventually happen, is the AP style questions will not give you the function. You won't get this. You will get a filled in chart sometimes. So you have to now compare this, think about what we did with these last week with our vertical asymptotes, right? So if there was a vertical asymptote, there was something that was undefined, right? And as one side was approaching and getting closer to that, what was happening to the numbers? So if there's a vertical asymptote, the numbers were getting either really big, yes, or really small. Do we agree? Yeah. So as it's getting closer to a vertical asymptote, they're going to grow drastically or decline drastically. But they are going to definitely change. It's going to get bigger, 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 bigger. We know it's increasing without bound. That's what happens around a vertical asymptote. Now what's happening around this hole? What happens from when you plug in 3.999 to 4.001? What am I skipping over? 8, okay? And it's only skipping over it. It continues on in that direction. That's how you identify the difference between a hole and a vertical asymptote, because you are literally going to get given a chart and you have to know, is this chart describing a hole or is this chart describing a vertical asymptote? So we know it's around whatever's undefined. That's going to cause either a vertical asymptote or a hole. If it's a vertical asymptote, as it's getting closer to that, they are going to increase or decrease without bound. It could go in either direction, but it's going to be getting a lot bigger or a lot smaller, okay? Whereas a hole, it's literally skipping over something. Does that make sense? So this is a hole, okay? The x coordinate of my hole was 4, and the y coordinate of my hole is 8. And I can determine that with just the chart. I don't need the equation from it. Obviously, if they give you the equation, I can do x plus 4, x minus 4 over x minus 4, and know that x minus 4 is getting crossed out, so 4 is the hole. And then to plug it back in, I'd get 4 plus 4, which is 8, and that would give me the y coordinate of my hole, okay? But you also have to be able to do this without the equation, so the chart would already be filled in. All right, so now let's do the limit notation as the limit of my graph as x approaches 4 from the left, and the limit as x approaches 4 from the right. F of x equals 8. Good. Now, if you look on your graphing utility, if you hit graph, you actually get a line. Because what's left here is f of x equals x plus 4, which is a line with a y-intercept at 4 and a slope of 1. What you will not see is the hole, and you have to know it's there. All right, now we're going to use the graph to answer all of these things. So it says use the graph of the rational function f to find the following. The first one says a, f of 6. So I'm going to go to my graph. I'm going to go to where x is 6, and I'm going to find the corresponding y, which is also 6. Then I'm going to go to B, where f is 2, and 2 is here. And I'm going to find the corresponding y. What's happening at 2? Good. So y would be undefined. I go to C, and it says the limit of my graph as x is approaching -5 from the left. So -5 is here. What's happening as it's coming in from the left? The y, it would be 2. As it's coming from -5 from the right, also 2. Oh, I went out of order. No, I didn't. C, x approaching 2 from the left. So as I'm getting closer to 2 this way, what's happening to my graph? -infinity. And as I'm going to 2 from the right, +infinity. And as x goes to negative infinity, now we're describing our end behavior. As it's going to negative infinity, what's happening to the y's? Positive infinity. As it goes to positive infinity, what's happening to the y's? Positive infinity. Now let's describe the domain of this function. So the domain starts and stops with every whole or vertical asymptote. So my arrow starts on the left. There's an arrow, which means it starts at negative infinity. And where's the first time it stops? At the hole at negative 5. Then it picks up again from negative 5. And when's the next time it stops? Good, the vertical asymptote at 2. And then it picks back up at 2. And because this arrow is pointing up and right, it goes to positive infinity. So again, domain would be impacted by every vertical asymptote or hole. Still good? All right, so this one says, here we have, this is a sign chart, right? So it's giving me ranges. It's telling me my function is either positive, which would be above the x-axis, 0, which means at the x-axis, negative, below, or undefined, which could be a hole or a vertical asymptote, okay? And it's asking you, for the first one, which of the following must be true for the function of f? So first of all, if you need a visual, get a visual. You have a 0 at negative 3. 1, 2, 3. So at negative 3, it's 0. At 0, it's undefined, which either means it's a hole or a vertical asymptote. We don't know yet. At 2, it's 0 again. From negative infinity to negative 3, it's positive. So it is above my x-axis here. Then it hits the x-axis, and then from negative 3 to 0, it's negative. So it's coming below my x-axis. It's undefined at 0. From 0 to 2, it's negative, which means it's under my x-axis. It hits the x-axis at 2, and then it comes above the x-axis. So it's positive. You with me so far? All right, so it says, A, the graph has a minimum at negative 3 and a minimum at 2. Does it have to be true? No. B, it has a minimum at negative 3 and a maximum at 2. Nope, because it can't have a minimum because it's continuing on to be negative, right? No. C, it has exactly 2 distinct real zeros. Could be true. Has exactly 3 distinct real zeros. Nope. The graph has a vertical asymptote at x equals 0. Could be true. So because it didn't, here's 2 things. One, this side went to negative infinity and this side went to positive infinity. That means this behavior never changes. It always stays above. It never comes back below again, which means it's never going to hit the x-axis again. Does that make sense? And because this continues on forever in this direction, because we go to positive infinity, it's never going to dip back down below the x-axis, okay? So, has distinct 2 zeros, could be possible, and it has to have a vertical asymptote at 0. What would be the other option that would make it undefined? A hole. So there could be a hole here. It could come down and it could come back up again. We don't know the overall shape of that. Does that make sense? So the only thing we know for sure is it's not going to cross the x-axis again. Now the next one says, which of the following could be an expression for f of x? Well, I know it has to be undefined at 0, right? Which means in my denominator, I need an x there. So this would be undefined at 0. 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 But there's other ones there too. If anything else is in the denominator and it's not, well, these would cancel, right? And these would cancel. And these would cancel. And these would cancel. So they would all cancel out the 0 in those cases, which means it could be a hole or it could be a vertical asymptote. But the other 2 that are there, here, I've got an x plus 3 and an x minus 2. What would have to be there if they're in the denominator? Those would have to be vertical asymptotes, right? There'd have to, for C, there'd have to be a vertical asymptote at negative 3 and positive 2. And for D, there'd have to be a vertical asymptote at negative 3 and positive 2. So we can rule those out. Now look at the signs in A and B. What's different? This would say there's a 0 at -3 and +2. This would say there's a 0 at +3 and -2. Where were our zeros? -3, +2, which means A could have been the equation of this graph. Questions? All right. Example 6 does all of the above. Find the domain. Find the zeros, the y-intercept, the asymptotes, the holes, and graph. When you're checking for asymptotes, this is vertical asymptotes, horizontal asymptotes, and slant asymptotes. All right, so what's the one thing you do after you factor but before you cancel out if you can? Domain. That's the only thing, okay? So I'm going to factor first x squared and then x minus 2 and the denominator x plus 6 and x minus 3. And then before I do anything, I do the domain, which is that these can't equal 0. So domain is just -6 and +3. -infinity to -6, -6 to 3, and then 3 to +infinity. Then I check to see if there's a hole. So can I cancel anything from the top and the bottom? And you can't, which means there's no holes. Then I do vertical asymptotes. So vertical asymptotes, we just change these not equals to equals. So I get x equals -6 and x equals +3. Those are my vertical asymptotes. -6, +3. Then I would see if there's a horizontal or slant, right? What's the rule about my exponents? Slant would be one more, right? It can't have horizontal if the one in the top is bigger, so there's no horizontal asymptote. But the one in the top is one bigger, which means there's a slant asymptote. To do that, I go back to the original. So I'm not going to worry about it once it's already factored. I'm going to keep it in its original form. So I would get x, can you see that? No. X to the third minus 2x squared plus 0x plus 0, because it's missing both those terms. And that gets divided by x squared plus 3x minus 18. And then it's first into first. So this would be x, multiply it out, x to the third plus 3x squared minus 18x. Change your signs. These cancel. Negative 5x squared plus 18x plus 0. And then repeat the process again. So what would I have to multiply x squared by to get to -5x squared? And it's -5. And as long as that first one cancels, I don't even care about the rest of this. Once I change this sign, if it cancels, I ignore the remainder. I don't need it. What I need is up here at the top. And that's my equation, y equals x minus 5. And I graph it. So there's a y-intercept at -5 and a slope of 1, which means my slant asymptote would look something like that. Yep.
So we would put, like, if they ask for the slant, we would just put the equation.
Yep. It has to be y equals, but it's whatever your quotient is at the top, ignoring your remainder. Yep. And then it asks for the zeros. So if I factored it and then I set each of these equal to 0, I get x equals 0. And how many times is 0 an answer? Twice. Why is that important? It's gonna bounce at 0. Yep.
Why is the -2x squared plus 3x squared -5x squared?
Why? Say that all over again?
In the division.
Yeah.
The -2x squared plus the 3x squared.
Because I changed the sign. So it was plus, but I made it minus because you're doing minus. And you either have to change the sign and add, or you have to subtract. Okay, so then the other zero's at 2, which means it also crosses through at 2. And then there's no other zeros, which means it doesn't cross my x-axis at all. I could also find my y-intercept, so I plug 0 in for all these zeros, 0, 0, 0, 0. I end up with 0 over -18, which is 0, which is consistent with that hitting the x or the y-intercept at 0. So now let's say I know nothing else about this graph, right? I know where my asymptotes are. I know where my zeros are. I do know it bounces there, okay? But I know nothing else about the behavior. This is where extra points would come into play. So you usually don't ever have to plot these by hand. Like you never usually have to draw them out in fully, but you might have a multiple choice. And it could say which of the following are them, okay? So what happens when you have two vertical asymptotes is the end behavior is going to be impacted if there was a horizontal asymptote or a slant, which means it's either going to go here and here, okay? Or it goes below and above the other way. Hang on. This would still go, and it would go in this corner and this corner. And the way you would find that out is literally plotting a point. Like I would plot a point that is bigger than 3 and plot a point that's less than -6 and see if it's above or below that slant asymptote. Okay, that's how I would do it. Then to find out what's happening in between, if there's a horizontal asymptote, different behaviors happen. It could be like a parabola shape. That would be easy to find if it bounces, okay? But when you're dealing with a slant and then two vertical asymptotes, weird things happen here. Typically, it looks almost like a cubic function, especially if it bounces. So it might be something that's above here, because it doesn't cross through. It could be above here, it could bounce, and it could come back through. Is what it could look like, okay? But to be more accurate, I would say what's happening in between here, I would take a point, I would plug it in, and I would see is it above or below, okay? I know it doesn't cross, so that's a big thing. That tells me it's not happening here because it would cross, right? Like if this was where my curve was, I would have had another 0, and that's not happening. Or if this was here, I'd have another 0, and that's not happening. So that's where I gather that it looks pretty much like this, okay? And if it was multiple choice, that would probably get me enough information. I would know the zeros couldn't exist, which means I can't have it cross through there. Emma?
What's that point next to the middle?
These were 2 zeros. Like I had a 0 at 0 and I had a 0 at 2. Is that what you mean? Yeah. So it had to hit and bounce off here. It could have gone below it, but because of the behavior that it's like bouncing and then still crossing through here, I kind of knew that that had to happen. But if you didn't know, if you had no idea, you would just plot the point. Like plug in a point here and see what happens to your graph. And you can plug in the point to your factored function. I could plug it into x squared times x minus 2 over x plus 6 and x minus 3. Or I could plug it into the original one. It doesn't matter because we didn't actually alter it. We just factored it. All right, one more and then we're done for the day. So again, domain, zeros, y-intercepts, asymptotes, holes, and graph. I'm going to give you 3 minutes to get ahead. Okay, so first of all, the very first thing I would do is factor it out and then find my domain. So neither of these can equal 0, which means x cannot equal 0 and x cannot equal -2. So my domain goes -infinity to -2, -2 to 0, and 0 to positive infinity. That has to happen before we cancel out. Then you can cancel your x plus 2's from the top and the bottom, and what's left is 1 over 3x. And everything from here on out comes from here, okay? 1, because I canceled out, that means there's a hole. And if I set that equal to 0, then the x coordinate of my hole is at -2. If I take that and plug it back in, it has to go into my updated one. So it would be 1 over 3 times -2 or -1/6. So that's where the hole is. Now using my updated function, I find the rest of the stuff. There's no zeros because 1 could never be 0. So there's no zeros, okay? If I do my y-intercept, I get 1 over 3 times 0, which is 1 over 0, undefined, which means there's no y-intercept. To get my vertical asymptote, I'd set the bottom equal to 0, and my vertical asymptote occurs at x equals 0. The exponent in the top is 0. The one on the bottom is 1. That means the top is smaller than the bottom, which means there's a horizontal asymptote at y equals 0. And it means there's no slant. So then I plot what I've got. Vertical asymptote at 0. Horizontal asymptote at 0. No x-intercepts, no y-intercepts, which means it's happening in these corners, but I don't know where. Okay, but I do know there's a hole at -2 and -1/6. So at -2 and -1/6, there's a hole, which now tells me this is in this corner. And if you remember your parent functions of reciprocal functions, they're in opposite corners. If you don't know that, then you plug in a point. Like if I just plugged in 1, for example, I'd get 1/3 times 1, which is 1/3. So I have a point at 1 and 1/3, which means I'm above my x-axis. And those reciprocal graphs are in the opposite corners, okay? Questions? Okay. Homework is again a PDF. The AP classrooms will save for your test review on Monday.